Hello everyone, myself Vinay Kumaram. I am pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So in my previous video, I was actually discussing the 8th chapter of 9th standard science subject that was on force and laws of motion. So in my previous video, I was actually discussing about the Newton's first law of motion. So in this particular video, we will be discussing about the second law of motion which Newton has stated. So before going into the second law of motion, we will try to look at some examples. For example, on a road, if a particular vehicle is there, so let's say a big bus is there on a particular road. So this particular bus which is there on this particular road is at rest. It is not moving. So that means the velocity of this particular bus is 0. So here velocity will be equal to 0. Now if a particular person is standing here, then even though this particular bus has certain mass m, so bus will be having certain mass. Let us say that mass as m. So even though if this particular bus has mass m, still this bus is unable to hurt this particular person. So even though certain amount of mass is present in that particular bus, still it cannot hurt a person who is standing in front of that particular bus. Now let us say there is one more road and there is one more bus. So this particular bus will be having certain velocity which is not equal to 0. That means it has some velocity and also some mass will also be there for this particular bus, and that is very obvious. So now if a particular person is standing in front of this particular bus, then this bus along with its mass and velocity, it is capable of hurting this particular person. So that means here initially the same bus which was having velocity 0, the same bus which was having velocity equals to 0, even though it has mass in it, it cannot hurt a person who is standing in front of that particular bus. But now this particular bus, when it has certain amount of velocity and this particular bus already has some mass, with this mass and velocity, with the combination of this particular mass and velocity, it has capability of hurting or even killing the person who is standing in front of this particular bus. So that means here the impact which that particular person is receiving. So here this particular person who is standing in front of a bus which has certain velocity, so the impact of this particular bus on this particular person, so this bus has certain impact on this person. So that means here this particular bus has an impact on that particular person. That means a bus with a certain mass and with certain velocity can have certain impact on an object which is coming on its way. That means here to understand that particular impact of that particular object on another object, we have to define a particular physical quantity. And that physical quantity was introduced by Newton, and that is known as momentum. So here Newton introduced a new physical quantity which is known as momentum, which is equal to the mass times velocity, that is product of mass of that particular object and velocity. So that means any object with a certain mass, if it has certain velocity, then it carries some amount of momentum with it. That means here if any object comes on the way of that particular object which is having certain velocity, so in that opposite direction if a particular object is placed or if a particular object is coming, then this particular object can have an impact on that opposite object which is coming opposite to it. So the new term which you should remember here is momentum. So now if a particular bus is actually traveling and there is one big wall in front of a particular bus. So let us assume this as a case. So now this particular bus will be traveling at certain velocity v. and this particular bus also has some mass m. So now, as I discussed, this particular bus with mass and velocity has certain amount of momentum. So momentum always it is represented as small p. So p is equal to mv. That means with velocity, this bus has some momentum. Alone this momentum cannot have impact. When this momentum is changed with respect to time, then only that momentum has an effect on the other object. So for example, here this particular bus, let's say it go and hits this particular wall. So when this particular bus goes and hit the wall, at that particular time, the amount of time which it takes to hit the wall, so that will define the change in momentum. So that means suddenly velocity will be dropped, because when a particular bus or any particular object is crashing with other object, suddenly its velocity will be reduced. Because let's say this is a bus which is moving at a certain velocity. Suddenly when there is an obstruction, the movement of this particular bus will be ceased. Here that shows velocity is reducing, because when a particular object is hitting another object, its velocity will be reduced. So when its velocity is reducing, that means here momentum is changing. And here one thing you should remember, how much time it takes to reduce the velocity. How much time, always remember the word. So how much time it is taking to reduce the momentum. So how much time it is taking to reduce the momentum. So instead of writing momentum, I'll write P. That much amount of less impact will be there on other object. Because when it is taking a lot of time to reduce its velocity, that means momentum is slowly reducing. So that means impact will be very less. Suddenly, if a particular bus or a particular object suddenly crashes with a wall and suddenly velocity comes to zero, that means without taking more time, within lesser amount of time, velocity is coming to zero. That means there is a rapid change in momentum. So whenever there is rapid change in momentum, whenever there is rapid change in momentum, then impact will be very high. So the object which will be receiving the impact will receive more impact if the momentum is suddenly decreased or increased. Now to understand this, we will take one more example. Let's say a particular batsman has hit a ball. So, and that particular ball will be traveling in air, and on the ground there will be a fielder who will be ready to catch this particular ball. So in a cricket match, when a batsman hit the ball and when it is traveling in air, the fielder who will be assigned to catch that particular ball in a particular position, he will be waiting for that ball, and suddenly when the ball comes to him, he will catch the ball and he will pull his hands back while catching the ball. Why a particular fielder has to do that? Why? Because here he is giving more time for the ball to reduce its velocity. So this particular ball which is traveling in air and coming towards this particular person has certain amount of velocity. And we also know that this particular ball has certain mass m. So here this particular ball is already carrying certain amount of momentum. So when momentum is changed, then impact will be very high. So that means suddenly if a fielder catches ball like this, just like this if he catches, then impact will be more, because suddenly he is putting his hands in the way of the ball and suddenly the velocity of ball is reaching zero. So immediately when the velocity of the ball is reaching zero means there is rapid change in momentum. So there is a lesser amount of time. So this lesser amount of time will increase the impact. Now we will understand this with certain equations. Rate of change of momentum is always equal to, so instead of writing momentum, I'll just write P is equal to force. So what is rate of change of momentum? Rate of change of momentum is momentum changing with respect to time. So what is happening here basically is that the initial velocity u is coming to a final velocity. So whenever there is rate of change of momentum, here there will be certain amount of initial velocity. For example, if a bowler is catching a ball, so at that time he is actually catching that ball, so that ball before reaching his hands will be having certain amount of velocity. That will be considered as initial velocity, and when it comes to rest, or when the velocity of that particular ball will be changing, that will act as its final velocity. So suddenly when he catches the ball, the velocity of ball will reach to 0, or some lesser amount of velocity will be there. So that particular velocity will be the final velocity. So here, if I have a particular bus, and if this particular driver of this particular bus will apply some amount of brake, so that means here initially this bus will be traveling at speed u, and when this particular person will apply that much amount of brake for this particular bus to reduce its speed, so its speed will be reduced to a certain amount of velocity, let's say v. So now initially this particular bus, when it was traveling at velocity u, suddenly came to velocity v. So initially the momentum was m times u, now the momentum has reduced to m times v. So that means here there is change in momentum. So change in momentum is equal to, it has changed from mu to mv because the velocity has reduced. So change in momentum will be equal to mv minus mu, because mv is the final momentum and mu is the initial momentum. So change in momentum will be mv minus mu. So when you take m common from this, it will be equal to v minus u. So now change in momentum is m into v minus u. Rate of change of momentum. So that means always I have mentioned you that whenever rate of change of is coming with respect to some physical quantity, means that particular physical quantity is varying with respect to time. So rate of change of momentum, instead of writing momentum, I'll just write P is equal to m into v minus u divided by t, time. So here mass times velocity, final velocity minus initial velocity divided by time will give you rate of change of momentum. So you all know equations of motion. So first equation of motion, here we have v is equal to u plus at. So now if you bring this u to LHS, it will be v minus u is equal to at. If you bring this time to the other side, then it will be v minus u divided by t, which is equal to a. Here also we have v minus u divided by t. So that means here mass times acceleration you can write. So here rate of change of momentum is equal to mass times acceleration. So if you look at the statement of Newton's second law of motion, here the rate of change of momentum is proportional to the applied force in the direction of force. So what do you mean by this? So now always remember, if a particular object is moving on a particular road with a certain velocity, if you want to increase the velocity or decrease the velocity of this particular object which is traveling at uniform speed, then you have to apply an extra force so that this particular object will move fast. And if you apply the same force from opposite direction, then the velocity of this particular object reduces. If the velocity is increasing, initially if it was traveling at velocity u, then it will be having momentum equal to mu. Now its momentum has increased because the velocity has increased. So the second momentum p2, if it is p1, then second momentum p2 will be equal to m times v. So that means here from mu it has changed its momentum to mv because of the external force. So that means this particular force is known as unbalanced force. If you want explanation about unbalanced force, you can refer my previous video. So here, because of this particular unbalanced force, there is increase in velocity. So here, when force is applied to this particular object, there is change in velocity, there is increase in velocity. So when there is change in velocity with respect to time, that is actually acceleration. That means here force is directly proportional to acceleration. If the force is applied in the same direction in which object is moving, then the object will be accelerated. If the same force is applied from the opposite direction for the object's direction, for the movement of the object's direction, that particular object's velocity will be reduced. That means acceleration is happening in the negative direction. That means deceleration is happening. That means here force is directly proportional to rate of change of momentum. So force is directly proportional to rate of change of momentum. So that means here if force is increased, then rate of change of momentum is also increased. So what is rate of change of momentum? Rate of change of momentum is mass times acceleration. Introduce a constant to remove this proportionality symbol. So F is equal to kma. So now if you are considering 1 kg mass, and if you are considering 1 meter per second square acceleration is happening, then force will be equal to 1 kg meter per second square. So here at that particular time, 1 is equal to k into mass is 1 kg, acceleration is 1 meter per second square. So that means k will be equal to 1. So if k is equal to 1, then F is equal to 1 into ma. So that means here F is equal to mass times acceleration. So here if you want to consider the unit of force, you should consider the unit of mass. So unit of mass is kg and the SI unit of acceleration is meter per second square. So meter per second square. So the unit of force will be equal to kg meter per second square. So this was actually discovered by Newton. Hence kg meter per second square is named after Newton's name, that is Newton. So you should always remember whenever you are writing SI unit, if you are writing complete name of that particular SI unit, then you should always start with small letter. If you are just writing the first letter of SI unit, that is N, so here first letter of this particular SI unit is N. So here you should always remember you should use capital N and you should just stop there. If you are expanding that Newton, then you should use small n. So if you are actually mentioning the scientist name, then you should use the capital N because you are actually referring a name of a person. So whenever you are referring a name of a person, then you should use the capital letter. But if you are using the same scientist name as SI unit of some physical quantity, then you should use the small letter. If you are using the complete expansion, if you are not expanding that SI unit, you should use the capital letter of the first letter of that particular SI unit. So Newton is the SI unit of force, which is actually equal to kg meter per second square. So always remember force has SI unit equal to, so SI unit of force is either capital N or small n with expansion, that is Newton. So Newton is the SI unit of force, or kg meter per second square is the SI unit of force. So now if you want to define what do you mean by Newton, if a particular body has 1 kg mass, so if that particular force is responsible to accelerate that 1 kg massed body with acceleration equal to 1 meter per second square, then that particular force will be equal to 1 Newton. So that means here 1 Newton is the amount of force which generates 1 meter per second square acceleration for a 1 kg massed body. So this is the definition of Newton. So all these things are there in the textbook. You can go through the textbook. You can watch this video multiple times so that you will understand what you mean by momentum, what you mean by rate of change of momentum. So this is all there in this particular video. Like this, if you want to learn more physics, chemistry and mathematics, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.